Today's lesson will be looking at Chemistry 1501. We are going to be looking at ideal gases. We are going to be focusing on how to apply this equation PV is equals to nRT. This is lesson 102. Let us start. In lesson 101, we looked at introduction, and we also looked at the proper SI units to use when we apply this equation. And we did mention that we have two values of R, or let me say we have two ways to express the value of R, but throughout this lesson video I'll be using this value. So you can see that this SI unit for the value of R is the combination of SI units that we have here. So in this case I'll be using liters for volume, I'll be using atm for pressure, I'll be using K for temperature, I'll be using mole for the number of moles. So in this lesson video, we'll be looking at many examples on how to apply this equation. And for now, I cannot be specific how many examples we're going to be looking at, but I'll try to do as many as I can. And just make sure that after the first 2 or 3 examples, you start practicing. Meaning that once I display the question, you pause the video, you work out the question, you play the video, and to verify whether you got the answer correct. This lesson video is also a practice question on how to apply this equation. So let us start with our first example. Our first example, if I have 4 moles of a gas at pressure of 5.6 atm and volume of 12 liters, what is the temperature? So we are looking for the temperature. Now in this case, we start by looking at the SI units. You can see that the number of moles is measured in mole, it's correct. Then we also look at pressure, it's in atm. And then we look at the volume, it's in liters. So we are good to go to actually substitute to the equation and start solving. So our pressure is 5.6. We are looking for the volume. Our number of moles is 4. And then we know that the value of R is 0.082. And then our temperature, actually we are looking for the temperature, not volume. So our volume is given as 12 liters. Then temperature is the one that we're looking for. So what we can do now, we can just divide by 4, 0.082 both sides. So you can see that this will get rid of this. Then temperature is equals to this. So our temperature is 204.88 kelvins. Our next question, it says, if I have an unknown quantity of gas at a pressure of 1 to 1.6 kilopascals, a volume of 31 liters, and a temperature of 87 degrees Celsius, how many moles of gas do I have? So we're looking for the number of moles. Let us start by looking at the SI units. We have kilopascals, we must convert to atm. Liters is correct. Then we can see that the temperature is in degrees Celsius. We must convert it to kelvins. Now, if we are going to use this value of R, then it is very important that our temperature is in Kelvin and pressure is also in atm. So let us start by converting. Now, you know that from kilopascals to atm, we divide by 101,325. Lesson 101, we did cover the conversions, and then from degrees Celsius to kelvins, you're just going to add by 273. So 121.6 divided by 101,325, we are going to get our pressure as 1.200 atm, and then kelvins, 273 plus 87, we are going to get 360. So 360 is the new temperature that we are going to use. So our equation PV is equals to nRT. We are looking for this N, so we can just go ahead and make N the subject of the formula. We are going to have PV over RT. Then this is equals to 1.200. Our V is 31, all divided by R is 0.082, and then our T is 360. Our N is equals to 1.260 mole. Our next question, if you contain 3 moles of gas in a container with a volume of 60 liters and a temperature of 100 Kelvin, what is the pressure inside the container? So we are actually looking for the pressure. Looking at the SI units, we can see that mole is correct, liter is correct, K is also correct, so we can go ahead and use our equation. So P will be the subject of the formula in this case. So when we substitute, we have 3 moles of this gas and then 0.082, temperature is 400, then our volume is 60. The pressure will be 1.64 atm. I hope you got this one correct. Let us move to the next one. Our question number 4, it says, if you have 7.7 moles of gas at pressure of 0.09 atm and a temperature of 56 degrees Celsius, what is the volume of the container that the gas is in? So in this case, you're actually looking for the volume. Now pause the video, work out this question, play the video to verify your answer. Now looking at the SI units, this is correct, this is also correct. The problem is this one, we should convert it to kelvins. Now to convert this to kelvins, we're simply going to add 273, which the new temperature will be 329, or let me say the temperature in Kelvin is 329. So let us go ahead and substitute to our equation. PV is equals to nRT. We are looking for the volume, so the equation will be V is equals to nRT divided by P. Substitution 7.7, R 0.082, temperature is 329, divided by our pressure is 0.09. The volume will be 23,008.12 liters. Our next question, it says, if you have 17 moles of gas at temperature 67 degrees and volume of 88,890 milliliters, what is the pressure of the gas? So we are looking for the pressure in this case. Looking at the SI units, we can see mole is correct. Now we need to add this, we need to add 273 to convert it to kelvins. Then we can see that from milliliters to liters, we also need to multiplied by 10 to the power negative 3. So in this case, let us start with our temperature. 67 plus 273, it will give us 340 kelvins. And then looking at the volume, we are going to get 88.89 liters. So we can go ahead and use our equation. Since we're looking for the pressure, the equation will be like this. And then number of moles is 17. R is 0.082. And then our T is 340. All divided by 88.89. Our pressure is 5.31. Not 31, actually it's 33 ATM. I believe you got this correct. Let us go to the next one. Question number 6. It says, if you have 1.9 moles of gas held at pressure of 506.625 kilopascals and in a container with a volume of 50,000 milliliters, what is the temperature of the gas? So we're looking for the temperature in this case. Let us quickly look at the conversion. It's correct. Now we need to convert this to ATM. Also convert this to liters. So converting this to ATM, we divide by 101.325, which we are going to get 5 ATM. And then 50,000 milliliters to liters, we are going to get 50 liters. So looking at our equation, PV is equals to nRT. We are looking for temperature, so it will be T is equals to PV over nR. Our pressure is 5. Our R is 0.082 divided by N is 1.9. Actually, I made a mistake here. This is supposed to be our V, then R will be at the denominator. So it will be 5 multiplied by 50. And then NR is 0.082. So temperature is 1604.62 kelvins. I hope you got it correct. Our next question, remember, you pause, work out, play to verify. If 4 moles of gas at temperature 5.4 atmospherics have a volume of 120 liters, what is the temperature? So in this case, you can see that our conversions or our SI units are correct. So we can go straight to our equation. In this case, we are looking for the temperature. So T is equals to PV over nR. .4 multiplied by 120. Our N is 4, and then we have 0.082. Our temperature 1975.61 kelvins. Our next question, a certain quantity of argon gas is under 16 torr pressure at 253 Kelvin in a 12-liter vessel. How many moles of argon are present? Now in this case, you can see that the SI unit of pressure is in torr, so we need to convert to ATM. To convert to ATM, we are going to divide by 760. So our pressure in ATM is 0.021 ATM. And then you can see that the temperature is well, and also the volume is also well. So PV is equals to N of T. In this case, you're looking for the number of moles. So N is equals to PV over over RT. So our P is 0.021, V is 12, R is 0.082, our temperature is 253. So the number of moles is 0.012 mole. I hope you got it correct. Our next question is a bit different. Our question says an unknown gas weighs 34 grams. So this is the mass of the gas in grams and occupies 6.7 liters. This is the volume at 2 atm, our pressure, and 245 Kelvin. This is the temperature. What is its molecular weight? So we are looking for the molar mass of that gas. So the equation to calculate the molar mass, or the equation that has molar mass, is this one. N is equals to M over M. This is the molar mass that we're looking for. This is the mass of the substance in grams. Then this is the number of moles in mole. So we are looking for this. We have this. We don't have this. So we can calculate this using our equation, because this N is the very same N we see here. So we start by calculating this N. Then from there our answer is going to substitute it A. Then we work out the molar mass. So this is our equation. We are looking for N. Then the substitution pressure is, let me actually substitute it here. Pressure is 2, and then volume is 6.7, and then we have our R as 0.082, temperature is 245, this is our number of moles. So substituting it here, or making the M the subject of the formula, we have N is equals to M over M. Then multiplying both sides by the term that causes the fraction. This will get rid of this. Then you have M is equals to M and N. Then we divide both sides by N. Then you're going to end up with this equation. M is equals to M over N. So this is the equation that we're going to use. So the molar mass is equals to the mass in grams is 34, 0.667. The molar mass is 50.97 grams per mole. Our last question, it says the pressure of 6.5 atm, 2.3 mole of Br2 gas occupies 9.3 liters. What is the temperature in degrees Celsius? So you're looking for the temperature but in degrees Celsius. So we can go ahead and use our equation. PV is equals to nRT. Then T is equals to PV over NR. pressure is 6.5, our volume is 9.3, N is 2.3, R is 0.082. So we get that the temperature is 320.52. This is in Kelvin, so we need to convert it to degrees Celsius. Remember we said the equation to calculate to convert from Kelvin to degrees Celsius, it's K is equals to C plus 273. So if you want to convert from degrees Celsius to Kelvin, it will be C. It will be, this color is not visible enough. It will be C is equals to K minus 273. Simply make this the subject of the formula by transposing this to the other side. So you can simply take this minus 273. We're going to get 47.52 degrees. I hope you got this one correct. Well, this is the first practice question for ideal gas. Do watch lesson 103 where we look at other equations, because we don't have only this equation. We have the combination of gas equation. You also need to know that, and we also have the equations that deals with the relationship between pressure and volume, temperature and volume, and also pressure and temperature. So it's very important that you watch this lesson videos under this chapter so that you get a better understanding of this chapter. That's it for this lesson video. This is Babula SJ. Thank you very much.